My name is and this video is tutorial for HTMpandaVis, which is tool for visualization of HTML systems in 3D space. If you never heard about HTML is hierarchical temporal memory, and it is foundational technology for the future of machine intelligence based upon the biology of neocortex. The company behind this is called Numenta, and the amazing thing about it is that Numenta has open source research. You can even watch online streams from their research meetings. Besides reading Numenta articles, I strongly recommend watching HTML school video series from Matt Taylor. They are just great. Now I will show you how to work with this tool. First requirement is that we need to use HTML core library. This library is former of NewPick. It is actively developed and I'm one of the guys working on this. Second requirement is to use so-called network API. It is API of this library that basically simplifies everything to building blocks and called regions and connections between them called links. So for example, you can have three regions: encoder, special pooler and temporal memory. You connect them with links and you must of course specify what exact output of region connect to what exact input of other region. Let's look at the first example. This is a HotGym example. It is experiment when we feed power consumption value and time date to the HTML network, and it tries to predict anomalies. Okay, so let's look at it. Here is the HotGym example script. In the HotGym example folder of the HTMpandaVis repository. It is just copy-paste from the HTML core library. In order to generate the data for visualization, we need to bake them. And in order to do that, we need to make this change. It is commenting out this line. This imports network from internal engine. And we need to import the network from the Panda Baker. It is basically just wrapper around the network engine internal object. Okay, so now I will show how simple it is to use the network API. Here is the creation of empty network. Then we add some regions. It's the date encoder, then the value encoder with parameters, and then the special pooler, and finally the temporal memory. Then we link them together. So for example, this link links the date encoder with the special pooler, and specifically it links the encoded output of the date encoder into bottom-up input of the special pooler. The same for the rest. Then we need to call network initialize, and then this is the iteration loop when we call the run function. Then we can retrieve some array or some value. There is the anomaly score, and this is just plots. Okay, so we can run it. Now it will store the state data for each iteration into the created folder. I can speed this up. It's finished. The 100 iteration took about 5 minutes. So at the end the plot is shown. We can close this and we will see what's inside the root of the script. There is the baked database folder. Inside is the SQLite file. We can look inside with some SQLite browser, and there is tables, as you can see. For example, links, the table links contains this data in simple form, and there are other regions, for example the temporal memory, the active cells of the temporal memory. You can see inside there is a blob data for each iteration, so this is like binary data for each iteration. There is also the folder with dump data, and these are really pure serialization of the classes. This is because of the performance. And the size of this file and this folder is 13.7 gigabytes. We can now run the Panda visualization. So this is the main screen. We must choose the database file location. For gym example, bake a database. Yes. Run PandaVis Explorer. Now it will create the graphics, and here is a main panel. We can see here 3 regions, but in fact there are 4 regions because temporal memory is unified with the special pooler. Basically special pooler operates on mini columns, and the temporal memory operates on the same mini columns but on the cells. We can also see the bursting columns with this option. So yellow columns are the bursting columns, and if we move farther into the simulation, we can now see that less bursting and more predictions are happening. And if we went to the 99 or 98, there is a lot of predictions and not so much bursting. So we can see that in the blue columns there is a predictive cell. Yeah, here. And these yellow columns are bursting. So all cells are active, and one is a winner. So all of them are active. This is winner cell, and this is also predictive. So let's look at another experiment. It is much more complicated experiment. It is the 2D object recognition project. You can find it on the HTM forum, and it is the concept is that we have input space and the agent with 4 sensors, and the agent moves around the input space, and it tries to learn sensory motor sequences. And this is the architecture. So this is in the script right now that I will run. It is based on 1000 brains theory. So let's run it. This will be much faster than the hot gym because this is there are not so much cells. So what happened is that we learn one object, it's called simple 1, then the second object simple 2, then the third object simple 3, and at the iteration 30 31, it starts to infer the simple 1 object. Now we will run the visualization. We will choose the database. Okay, it's done. So these are the layers or the regions. So this is the location layer with the grid cells. This is the L4 layer and the object layer. So we can go through iterations. So this is the learning of the objects. You can see here the motor input and the actual values. So these are activity bumps in the grid cells, and it moves around. So if we jump at the 31 iteration, this is the inferring. So at the first there is a lot of activity in grid cell layer, and it slowly narrows down to one bump per module. And also this representation of the object is narrowed down. So we can see 31. There is several objects in there, the union of several objects, and it narrows down to just single representation. We can also inspect each cell. There are apical connections, that's these, and we can see the connection to the grid cell layers. I want to show another feature, and that's dash visualization. It shows plots in web browser, so we can run it separately or with the 3D Explorer. So if I run it and click here, it's on localhost port 8050. I get this. These are interactive plots, so I can zoom it and stuff like that. Here we can see, for example, the activity in the grid cell layer. There is a drop of activity, so that's the narrowing. So the object is recognized. This is when inferring starts, and here is the object recognized. To define what data are shown here, one can just add more calls of this function update data stream. You put your label of the plot, and then you hand over the data. So this is the L6A representation, which is count of active cells. Definition of these layouts are in this folder. If you're stuck with some problem, just start a GitHub issue. I'm open for any collaboration for both PandaVis and to the Evolution project. So thanks for watching, and see you next time.